Assalamu alaikum wa rahmatullahi barakatuh. In previous tutorial, we already explained about how to create the room space inside the Revit, and after that how to export our GBXML file, okay, for the app. Okay, GBXML file, it means green building XML file, okay, which is created inside the Revit, and we can import in the app. Okay, so now in this session we will see how to import GBXML file and about the weather data. Okay, so let's see here project, okay, and import green building XML file. Okay, so import, and where we save our file, this is small, okay, and just open. So it is taking some times because of our file. It's depend on the file that how much space we have created. Okay, so it will take at least less than a minute. Okay, so do you want to display the GBXML translation report? This report provides a summary of translated data and report problem. So currently I no need, so no need. Okay, and the space which I created inside the Revit is here. See, first floor rental, ground floor rental, retail 01. Okay, all the spaces which I created inside Revit is already here with floor area, so it is very good. Okay, we save the time. Otherwise we have to put all this data in manually inside the app. Okay, so now we will see about how to calculate the heat load calculation. Okay, so let's see. First what we do, we go the weather data and we have to put the weather as per our location. Okay, so here see, we have to fill first the region. Okay, here region. Before that we can save this file to avoid any error. Okay, before that we can go the properties. See, here go to properties, and we can fill the name here. Okay, so what was the name? Mall, just simple mall. Number we can put anything, date, contact name, contact type. Okay, project manager, all the details we can provide here. So I put here in our name. Okay, and okay, and save. So mall. Okay, now it is, we are saving, change folder, and this is going to new folder. Here D, we can select our, yeah, this is the one. Yes, Revit SPSC inside. Okay, we can put here, we can create the folder here like have report, app report, and okay. Now save. Project mall was saved successfully. Now we can start our calculation whatever. Okay, but be sure without saving our file and mention all the identity data like properties like name and our like project information. Okay, so without this, if sometimes the error occur, then it will be all loss. Okay, so always be sure to save the file before doing any calculation. Okay, so here whether we can double click. Now region we can fill here. So the region is our Asia, because and location is New Delhi, India. Okay, and city is like New Delhi. Okay, you can put the location as per your choice or as per your project location. Okay, so Asia Pacific. Now latitude and longitude is automatically filled everything, all this data. Okay, but always we have to this this entry or this data we have to verify, cross verify. Okay, so before that I miss one thing here. The preference is SI metric. Okay, the unit is SI metric. You can select as per your project requirement, English or SI metric. I keep SI metric now. And here the project, what standard we are going to follow. Okay, so always select the latest one. This is for energy standard, and for ventilation always follow the latest one. So latest one is 2016. Okay, so and lead rating no required. Okay, so this data you can enter before starting the project. Okay, now weather, double click, and here again I have to select Asia Pacific, India and New Delhi. Okay, this data is okay, but you can cross verify. So for cross verify we have to go the online data. Okay, because here see the 2001 SRA handbook, it is all this data is following. So after that now 2026, so I have to be verify. Okay, so before this here now you can search simply SRA climatic data, select first one. Okay, here see 2021, also 2025 came, right? All these SRA climatic data. So 2025. Okay, now it is opening here because of the net, it is slightly slow. Okay, so see my location was New Delhi, right? New Delhi I can search here, and inside New Delhi if I will simply click New Delhi, India. Okay, so all these, so near the New Delhi the weather station where it is captured is some, this is the point. Okay, so where is our project location? I have to select the nearest location. Okay, if it is match then we can select our location, but it is some distance, so no issue, we have to always select the nearest one location. So see near to New Delhi the Lodi colony was taken this data from Lodi colony. Okay, one is from Rajnagar. So which one is near, like a 3 kilometer, 12 kilometer one. Okay, all this distance from the New Delhi. So nearest one is Safdarganj, so I can select the Safdarganj. Okay, now fine, see here Safdarganj. Okay, now this data here, the weather data is taken from 2025 SRA handbook, so it is always good. Okay, because our HAP here it is following 2021 SRA handbook. Okay, so now see the annual cooling here, what dry bulb we have to follow 0.4%. I already explained about 0.4, what is 0.4%. okay, so it means 0.4% here, 0.4% multiply, we can see 365, it means 1 here divide 100, right? It means 1.46 days only the temperature, this temperature will be more than 42 degrees Celsius. Okay, you know, it means in a year how much days? It is 365 or 66 days. Okay, so out of 365 days only less than 2 days, it means 1.46, less than 2 days the temperature will be exceed from 42.1 degrees Celsius. Okay, so this is the correct one and nearest one, and up to the mark we have to always select 0.4%. okay, taking the 42.1 degrees Celsius. So here what we will put the data, see here the latitude is okay, otherwise we can also correct this one, latitude 28.6 and cross verify. Here latitude is 28.58, so it is correct, 28.58, it means 28.6, so correct this one. Longitude 77.2 east. Okay, so what is here, 77.2, it is fine. Elevation is 215, how much here, 2015, so it is correct. What about the temperature? Here the elevation is summer design bulb temperature. Okay, summer design dry bulb. Okay, so summer design dry bulb is 41.7. what is the latest one? Because always climate temperature change due to the this pollution. Okay, so here 42.1, 42, so 42.1 I have to put. Okay, summer coincident wet bulb, so summer coincident, this is the one, mean coil wet bulb temperature. Okay, mean coincident wet bulb temperature, see mean coincident wet bulb temperature 23.7. what is here, 23.7. okay, now summer daily range. Okay, so what is summer daily range? Here hottest month dry bulb range 9.7. okay, so I have to put here 9.7. okay, now winter design dry bulb, so what is here, winter for heating, see here winter design dry bulb 6.7, but here heating dry bulb, this is for winter. Okay, because winter in winter we need the heating, so this is the annual heating. Okay, so heating dry bulb, it means 6, 6.7, so I have to follow 6. Okay, winter coincident wet bulb temperature, here wet bulb what is here? Winter coincident wet bulb temperature. Here it is mean coil wet bulb temperature. Also here mean coil dry bulb temperature. Dry bulb, okay? But we need mean coil wet bulb temperature. So how we will calculate this one? So here it is given like 2.7. Okay, now we will calculate. See, here the dry bulb temperature is 6. Okay, now we will come here in psychometric calculator, and here just we will click. Okay. It is not taking, so we will take the pressure from here. Okay, this is 98.77 kilopascal, right? So kilopascal, it means we will multiply by 1000 and we can convert this one in Pascal. So 98, we can calculate here, 98 points, what was 98.77, okay, multiply 1000. So 98, here just copy and here paste. Okay, altitude, if we required, we can also do here to, okay, this is dry bulb temperature. Okay, so dry bulb here temperature is 6, we can put 6. Now the relative humidity for comfort region, we all know that 50%, right? So all this now calculated. Here the wet bulb temperature is this T, it means difference. So this is the coincident wet bulb temperature. So now it is calculated 2.1. Here it was 2.7, so 2.1. Now fine, we fill this data from latest S-ray handbook, okay, not from 2001. Now see here, after that atmospheric clearance number, here if we come and press F1, here F1, so here it is showing, see, we can read all this one. Okay, for typical condition, 0.84 very hazy chart, okay, and 1.14 for very clear condition. So generally we take 1, okay, for typical condition. Fine, 1, it is automatically filled, default field. Average ground reflectance, click here and press F1. See, new concrete, all this data is taken from S-ray handbook, table 10, page 30.6. we can read. Okay, new concrete 0.31 to 0.34. so here 0.2 ground reflectance, so it is good. Okay, this is good. It means old concrete 0.2 to 0.25, so it is good. If it is new concrete, we can also 0.3. Right, soil conductivity, press F1. This is sand, apparent thermal conductivity. So sand, normal regime, this one, low this one, high this one. So we can put as per our material. Okay, 0.35 to 1.44, it means sand, so it is okay. Okay, a design, this is calculation month. Okay, so from January to December, it means whole year, so it is fine. Time zone is okay, no need to change here anything. Now design temperature is taken from here automatically. Okay, this is field, and design solar, no need. Simulation, no need, because we are doing the heating and cooling load calculation, not simulation. So okay, fine, okay. See, all this data is filled automatically, and we already verify this data from the latest one. Okay, fine. So next we will see the about space, which is very important also. So I hope you learned something from this video. If you learn, then subscribe and share with others. Okay, thank you very much. Assalamu alaikum warahmatullahi wabarakatuh.